Okay, so in the last video we were talking about solving with cubic equations, and one of the things we learned is that if you have 4 terms, you got to do grouping. If you only have 2 terms, like C and D, you want to use a cube of difference and sums. So let's practice first with grouping. It's a little bit easier to handle. And so with grouping, you want to have 4 terms, which we do here. So you group them up in pairs of 2s. And then from here, you want to pull out or factor out as much as you can. So there's an x cubed here and x squared. I can pull out at least an x squared. And I leave behind x minus 5. This one here's a 9 and a 45. So they have in common, or they can both be divided by 9. I'm going to pull out the 9, leaving behind the x, drop down the plus sign. 45 divided by 9 makes it a positive 5. But here's the thing that I forgot to mention. If there's a negative outside of the parentheses, then this sign needs to switch. So let's erase that real quick and make that into a minus sign. Here's why. If it was a positive sign, then negative times a positive sign makes this a negative, which it's not. But a negative times a negative makes it a positive sign, which is why we need that negative sign to be there. Also, since both of these are a negative 5, I can factor that out as x minus 5. And so I really left behind an x squared and a minus 9 as my other factor. So I'm taking the x squared and the minus 9, making it into its own factor or parentheses here. And now that I have everything factored, I can set them equal to 0 to solve. So x minus 5 equals 0 and x squared minus 9 equals 0. So I'm going to add 5 to both sides. This cancels. And looks like my x equals positive 5 for my first x. This one here I'm going to add over 9. And it looks like x squared is going to be equal to 9. Then I have to take the square root to get rid of the square. The square root is going to give me a plus and minus. Square root of 9 is a perfect square. So that's going to give me a 3. So it looks like x equals positive 5, positive 3, and negative 3. And so there are 3 solutions here. Okay, so for this problem here, again, it's another 4 terms. So I'm going to group this up and take out the x squared. And so if I take out an x squared, that means I only have one x here. Took away this x squared, so I only have a 6 left. I'm going to bring down the minus sign. And if I looked at both of these, this is a 4, this is a 24. So I'm going to take away a 4. That means I have an x left. This is going to change to a positive. So you took out a negative, you got to switch the signs. So this is a positive. 24 divided by 4 gives me a 6. So from here, both of these are the same. So I can factor that out. And I have left behind an x squared minus 4. I'm going to set both of these equal to 0. And then solve. So subtract 6 over, x is equal to negative 6. I'm going to add 4 over, x squared comes down, and this is a positive 4. But I have to take the square away. So I'm going to need to take a square root. That cancels. And so x equals plus and minus 2, because the square root of 4 is 2, but there's always a positive and negative. So there are 3 answers here, negative 6, positive 2, and negative 2. Okay, so that's for grouping. Let's see if we can do 2 terms. So 2 terms are a lot harder because you have to use the sum and difference of cubes, and then you might even have to use quadratics. So first, let's start with the difference of cubes. This is a minus sign, so I know I have to use the difference. So a cubed plus, or not plus, minus. There we go. So you might remember using SOAP. So same, opposite, always positive. So this will be a squared, a times b squared. So if I were to try to factor this, let's think about what is a and b first. So it looks like my a is going to be an x, because x cubed, x to the third power is going to give me x cubed. The cube root of 8 is 2. 2 to the third power is going to give me 8. So I know that this has to be a 2. If you're not confident in yourself, take the cube root of 8 in a calculator, and you'll find that it is 2. So 2 times 2 gives me 4, times another 2 gives me 8. And from here, I need to factor. So I know my x here is going to be my a, so this is going to be x minus my b. Oops, not b, 2. This is same. So same, always positive, and this is going to be our x. It's going to be a squared, and then this is a times b, so 2 times x gives me 2x. And then b squared is going to be 2 squared, which is 4. I'm going to set both of these equal to 0. So to solve this out, let me add 2 to both sides for the first one. So my x equals positive 2. This is the one that gets people. So on this one is a trinomial. You can attempt to try to factor it, but you'll realize you'll get stuck and you have to use the quadratic formula. So if you need the quadratic formula, I'll put it to the right of us. So the quadratic formula needs to be in standard form. It's always x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So in this case, let's figure out what is our a, b, and c first. Our a is always a number in front of x squared. B is always the number in front of x to the first power, so that's 2. And c is always the constant, which in this case is 4. So it's always in the order of its highest power to its lowest power. So that's a, b, and c. And so from here, I'm going to plug in my b. So it's going to be negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4ac, so 1 and 4 go in, times, on the bottom, 2 times 1, because 2a is on the bottom. So I'm going to try to clean this up now. So inside the root, 2 squared gives me 4. Drop down the minus sign. 2 times 1 times 4 gives me 16. And the bottom's a 2. So if I subtract the inside of the root, 4 minus 16 gives me negative 12. So again, I see another negative inside the root. So I'm going to try to pull that out and make that imaginary. So anytime I have a negative under the root, I know it's an imaginary number. Okay, so my next attempt is try to simplify the square root of 12. Let's do that to the side here. So 12 can be decomposed as 4 and 3. 4 can be decomposed as 2 and 2. So that is a pair. And I have a leftover 3. I've already used the 4. So it looks like I have 2 that comes out and 3 that goes back into the root. So this is negative 2 plus and minus 2i square root of 3. By the way, I always like to write the constant number that goes in front of the root. I like to put the I next to it. It just looks cleaner to me. It's just a preference. So from here, I notice all of these have a 2, so I'm going to try to reduce. So 2 divides into 2 one time, 2 divides into 2 one time, 2 divides into 1 time. So I can really write this as negative 1 plus or minus 1i, or just an I, square root of 3. Actually, I don't need the 1 in the denominator because if I write this over 1, it's a little bit redundant, so I can get rid of this fraction. And let me bring down this x. There we go. Looks like that's all I can do to combine. I can't combine these two numbers because this is imaginary and this is a real number. And that's pretty much it. So x equals positive 2, or x can equal negative 1 plus I square root of 3, or negative 1 minus I square root of 3. So there are 3 solutions here. So you can see cubics that have only 2 terms are quite difficult, but they're not too bad once you get used to them. But you have to use sums and difference of cubes first, find their factors, The first factor is easy to find x. This one you have to use quadratics because it's not factorable, so you'll go through the process of doing quadratics to find your last two x values. Let's do one more here. So with this one here, it's a little bit more challenging because there's a number in front of x cubed. Now this is a sum of cubes. So if you're doing a sum of cubes, you can use that formula. Let me bring this down just a little bit. Here we go. So you have a and b. If you use SOAP, this is going to be same, opposite, always positive. You have a squared, a times b, and then b squared. So if I were to find what my a and b is, let's go ahead and do that first. So this is going to be a, b. If I were to take the cube root of 8, we did this a moment ago, we got 2. And there has to be an x here. So if I take 2 to the third power, I get back to 8. X to the third power gets me back to x cubed. The cube root of 27 is 3, because 3 times 3 is 9, times another 3 gives me 27. So I found my a, I found my b. I'm going to try to factor this now. So same, opposite, always positive. I have a 2x for my a 3 for my b. Now I have to take the a and square it. So that means 2 gets squared, so that's a 4. X gets squared, so that's a x squared. A times b is 2x times 3, which is 6x. B squared is going to be 3 squared, so that's going to be a 9. All right, so I'm going to set each factor equal to 0 now. So this one here, I would just subtract over 3. That would cancel. 2x comes down. This becomes a negative 3. I'm going to divide over 2. That would cancel. X is going to be equal to negative 3 over 2, or negative 1.5, if you change that to a decimal. So I found my first x. This one here is a quadratic, and it has 3 terms. And I know that this one won't factor. So I'm going to go ahead and start using the quadratic formula. So my a is 4, because my x squared has a 4 in front. B is a negative 6, and C is at 9. And so using the quadratic formula, we have negative b, so negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 ac, so 4 times 9. And in the bottom, 2 times a, so 2 times 4. From here, I'm just going to clean up things that, like, there are 2 negatives here, so I'll make this a positive 6. The square root has a negative 6 and you square it, so that becomes a 36, a positive 36. I'll bring down this negative sign, but 4 times 4 times 9 gives me quite a large number here. Gives me about 144. And then from here, the bottom is 2 times 4, which gives me 8. And then I can try to subtract the inside of the root. So 36 minus 144 gives me negative 108. And the bottom's still an 8. So again, I have a negative under my root. So I'm going to try to get that out of my root by making this imaginary. Putting an I in front of the root. That gets rid of it. And 108 takes a bit of steps to think about how to decompose that. So let me put 108 to the side. So I know that maybe 3 can divide into it. So if I divide it by 3, it looks like it's 36. So 36 times 3 gives me 108. 36 can be decomposed as 6 times 6. And I could decompose these more, but because this is a pair, there's no need for it. So I've gotten rid of this. It looks like I have a leftover 3. So 6 comes out of the root, but 3 goes back in. So this could be 6i square root of 3. So I've changed this here to what I got when I decomposed that square root. And the bottom's still an 8. So from here, let's think about it. This is a 6, this is a 6, and 8. So if you're looking at just the numbers in front, they can all be divisible by 2. So I'm going to try to reduce this. So 2 goes into 6 3 times. 2 goes into 8 4 times. Just to make this a little bit cleaner. So we get 3i square root of 3 over 4. And then from there, I can't really reduce it any further. 3, 3, and 4 don't have anything in common. I'll bring down the x that was at the very top. So I think this is all I can do. It looks like x equals negative 3 over 2, and x equals 3 plus 3i square root of 3 over 4, or 3 minus 3i square root of 3 over 4. And that's it for this video. I hope you guys found this helpful. This skill right here is definitely going to be utilized in your project. Now, in your project, you're going to be given 4 terms, so you're going to be using grouping to solve this out. So one of your methods for solving is grouping. So come back to this video if you need help with grouping, so that way you know how to do your project. All right, I hope you found this helpful. Bye, guys.